Good morning, all. Let us discuss some more problems on wave equation. Okay, so in this problem, it is given that find displacement of a finite string of length L that is fixed at both ends and released from rest with initial displacement f of x. We know classical wave equation, one-dimensional wave equation, dou square y by dou t square is equal to c square into dou square y by dou x square. Okay, we have by using method of separation of variable, the solution is y of xt is equal to c1 cos px plus c2 sin px into c3 cos cpt plus c4 sin cpt. Okay, so we can substitute the initial values. So now you examine the problem, the displacement and velocity. First of all, we can see that boundary condition, that is the string is fixed at both ends. So we can say that y of 0t equal to 0 and y of lt equal to 0. Okay, y of 0t equal to 0 and y of lt equal to 0. These are the boundary conditions. Now since the string is released from rest and the initial displacement is given as f of x, since the initial displacement is f of x, we can say that initial displacement, that is y of x0 equal to f of x, and the string is released from rest, so that we can say that dou by initial velocity dou by dou t of y of x0 equal to 0. So we get 1, 2, 3, 4 conditions now, and we have the general equation for one-dimensional wave y of xt this. So we can first of all substitute the boundary conditions and find the update the equation. So we try to find c1, c2, c3, c4 here. Okay, first of all we substitute y of 0 t equal to 0. Since here the function is not clearly given, in some problems the function, instead of this function it is given that mu x into L minus x, or some function is clearly given, but here just f of x was given. Okay, that is the only difference in the problem. So y of 0 t equal to 0, we substitute that in the equation. What we get is y of xt equal to we can substitute this c1 cos px plus c2 sin px into c3 cos cpt plus c4 sin cpt. So we substitute x equal to 0. So what we get is y of 0 t equal to 0. So we get cos c1 plus 0 into c3 cos cpt plus c4 sin cpt equal to 0. Okay, from this we can say that c1 can be 0. Only the possibility is c1 can be 0. Then you update the equation, y of xt is equal to c2 sin px into c3 cos cpt plus c4 sin cpt. Okay, so now you apply the second boundary condition, y of lt equal to 0. Okay, so this will get sin pl equal to 0, pl is equal to n pi, p equal to n pi by l. We have done this in the previous problem, so I am not explaining that. So y of xt is equal to c2 into, we substitute instead of p n pi by l, sin n pi by lx into c3 cos c n pi by lt plus c4 sin c n pi by lt. Okay, we have this. Then we have the initial displacement as given as f of x, that is y of x0 equal to f of x. For this particular problem, since the function is not clearly given, so what we can do is we can do some different way so that we'll get this solution faster. Okay, so for this we first of all use the principle of superposition. So y of xt is equal to, we expect these for n we can have different cases, so all the sum of this solution is again a solution. So we expect sigma n equal to 1 to infinity c2 sine n pi by lx into c3 cos cn pi by lt plus c4 sine cn pi by lt. Okay, is a solution, is the solution. Okay, so now you for getting this more simpler, we can multiply this c2 the constants, and we can rewrite this equation as sigma sine n pi by lx into c2 c3 cos cn pi by lt plus c2 c4 sine cn pi by lt. Okay, now you can substitute this c2 c3 as an, this as bn. So our problem reduces to finding the constants an and bn. Actually we are doing all this to find the values for c1 c2 c3 c4. Now the problem reduces to finding values for an and bn. Okay, I will rewrite this y of xt. Y of xt is equal to sigma sine n pi by lx into an cos cn pi by lt plus bn sine cn pi by lt. Okay, now we just need to find an and bn. Okay, so for that we have the initial displacement is f of x, that is y of x0 is f of x. So we substitute t equal to 0 in the equation. So f of x is equal to sigma sine n pi by lx into n into cos 0 becomes 1 and sine 0 becomes 0. 1 plus 0. So that we get f of x is equal to sigma n into sine n pi by lx. So this is clearly the Fourier sums of sines. So we can say that by using half range Fourier series, we can see here instead of an we usually have bn for the Fourier coefficient, but doesn't matter, since it is the sum of sines we can use the half range Fourier sine series. So an becomes, an is equal to 2 by l into length of the string 0 to l f of x into sine n pi by l x dx. So we have received the value for our a. So there is some small difference to deal this problem, so we can use that here. Okay, okay, so we can do that. Hence we have received a value for a. Okay, but now to receive the value for bn we have to have the particular solution for, I mean particular value for the velocity, but it was not given. Velocity is 0, so we cannot do further. So if some velocity g of x is given, we can differentiate this and substitute values. Finally we can find the coefficient bn also. So this is the way how you do the problems which discuss or which gives displacement as f of x. Okay, now let us also discuss the velocity as g of x. If velocity is given as g of x, okay, if velocity is given as g of x, we can do further. Okay, we can do further. Let us suppose that the velocity was given as g of x. Okay, initial velocity dou by dou t of y of x 0 equal to g of x. So we start from here. We have the y of xt is equal to this particular thing. I'll copy this. Okay, so we'll start from here. So first of all, we find the derivative, partial derivative with respect to t. Dou by dou t of y of xt we will find equal to sigma sine n pi by lx into cn pi by l into an derivative of cos. Okay, minus sine cn pi by lt plus bn into cn pi by l into derivative of sine cos cn pi by lt. Okay, now when substitute t equal to 0, what we get is dou by dou t of y of x0. Suppose that is given as f of x, so sorry, g of x. Okay, so g of x is equal to sigma, instead of t you substitute 0, sine n pi by lx into, here the term becomes 0 because sine 0 equal to 0, 0 plus bn into cn pi by l into cos cn pi by lt. Okay, so what we get is g of x is equal to sigma bn into cn pi by l into sine n pi by lx. So this is clearly again a sine series. So the coefficient is this much. So only thing we have to focus is the coefficient is this much. So we can estimate the coefficients bn into cn pi by l by using half range Fourier series, that is 2 by l into integral 0 to l g of x into sine n pi by lx dx. Okay, by rearranging the terms, we get bn is equal to 2 by cn pi. Okay, 2 by cn pi integral 0 to l g of x into sine n pi by lx dx. So for the general function, what we get is bn is equal to this. So now you have to focus for the some problems which has low mark contribution. You can just say the wave equation is dou square y by dou t square is equal to c square into dou square y by dou x square. If the string is attached at both ends, we have y of 0t equal to 0 and y of lt equal to 0. For some general function f of x and g of x, that is y of x0, initial displacement is f of x and initial velocity is dou by dou t of y of x0 equal to g of x, we can clearly say that the one-dimensional solution of one-dimensional wave equation is y of xt is equal to sigma sine n pi by lx into an cos cn pi by lt plus bn sine cn pi by lt, where an is equal to 2 by l into integral 0 to l f of x into sine n pi by lx dx, and bn is equal to 2 by l into 0 to l g of x into, sorry, 2 by, instead of 2 by l we have 2 by cn pi. Here see that 2 by cn pi, I have mistaken here, cn pi. Okay, clearly write this, where bn is equal to 2 by cn pi integral 0 to l g of x into sine n pi by lx dx. So this is ultimately for the general function. But you make sure that for small mark contribution you can start directly from the wave equation and write this solution and substitute the initial displacement here and initial velocity here and do the problem. But for large mark contributions, what you have to do is you have to follow the derivation method that we have already discussed in the class and do all the steps and find the values for an or bn or an and bn together. Okay. So ultimately for the wave equation, dou square y by dou t square is equal to c square into dou square y by dou x square. There are some cases. Okay, one, first of all, the same case where the string is attached at both ends, so that we can clearly say that y of 0t equal to 0 and y of length of the string lt is equal to 0. This is same for all case because we deriving the equation for this case. Okay, now there are two different cases. One is we have given the initial displacement for some function and initial velocity dou by dou t of y of x0 equal to 0. And another case is we are provided with y of x0, initial displacement is 0 and initial velocity dou by dou t of y of x0 equal to some function. Okay, we'll identify this case by this term. The string was initially at rest and have a displacement. We identify this case by the string was at equilibrium position, this case by equilibrium position and allowed to vibrate. Okay, allowed to vibrate with a initial velocity. And next case is we have provided with y of x0 as some function f of x and dou by dou t of y of x0 equal to 0. And next case is similarly the initial displacement is 0 and initial velocity is some function. And on the final case is y of x0 equal to some function, initial displacement is some function and initial velocity dou by dou t of y of x0 is again some function. So all these cases we have to make sure that we know how to solve this particular wave equation. Now another type of problem we sometimes have is like this: a violin string of length L, length A with fixed at both ends, plucked at a midpoint and assumes initial shape of triangle with height h, and so a figure will be given. We have to find displacement. So for this kind of problem, the way you do is the similar that of we have discussed in the class, but only difference is we are not provided with the initial displacement or initial velocity in a straight manner. But we can say that the boundary conditions, since it is attached at both ends, y of x0 equal to 0, sorry, y of 0t equal to 0, and y of lt equal to 0. Okay, these conditions are same that of the previous condition. These are the boundary conditions, but initial condition we have to seek for some initial displacement y of x0 and dou by dou t of y of x0, initial displacement and initial velocity. So we have to seek this two. And this is given that it is plucked at the midpoint, assumes initially at a shape. It was initially at a shape and we hold that, but for that we can say that this initial velocity is equal to 0. First of all, we need to find the initial displacement y of x0 from this particular statement. Okay, So initially the shape is as in the figure. Okay, initially the shape is as in the figure. So it is at the midpoint, a by 2, height is h. Okay, so we can assume this shape. For that we have to say a, b, c. Okay, and to define the shape we have to say we have to find the function of ab, that is function of this line a, b. So a is point 0 0, clearly a is the point 0 0, and b is the point, see, a by 2h. Okay, a by 2 comma h. Okay, now you can use the particular equation of line. Slope is equal to y2 minus y1 divided by x2 minus x1, and the equation of line y minus y1 equal to slope m into x minus x1. You can use this formula to find the particular equation of or function of AB and BC. Let us find this. The slope m is equal to y2 minus y1. Okay, so we can represent this as x1 y1, x2 y2. So y2 minus y1, h minus 0 divided by x2 minus x1, a by 2 minus 0 equal to 2h by a. So to find the value or function of AB, you substitute y minus y1 is equal to m into x minus x1. So for simplicity we can use this x1 and y1 as 0 0. Okay, so y minus 0 is equal to m 2h by a into x minus 0, that is y is equal to 2h by a into x. So for the point from 0 to a by 2, the function y is defined as 2h by a into x. Okay, similarly you can find the slope and the function value for the other side. Okay, BC. Okay, I'll show that also. So for BC you can have these endpoints. This is BC. So B is a by 2 comma h, and C is x is point A and y is 0. Okay, so you can find these are x1 x2 and this is x1 y1 x2 y2. So slope is equal to m is equal to y2 minus y1 h divided by x2 minus x1, a minus a by 2 is again a by 2 is equal to minus h by a by 2 is equal to minus 2h by a. Okay, so now you substitute y minus y1 is equal to m into x minus x1. Okay, you can use this particular thing for simplicity. Okay, so y minus y1 0 is equal to m minus 2h by a into x minus a. Okay, so y is equal to minus 2h by a into x minus a, or is equal to, okay, 2h by a into a minus x, 2h by a into a minus x. Okay, from a by 2 to a. So we have initially y of x0 is equal to these two part. So you can proceed with the same kind of problem, and for the integral, finally when you get the integral 0 to a is the length of the string. Okay, into y of x0, that is f of x into sine n pi by lx. Instead of this you can convert this integral into two part, 2 by l into, that is integral 0 to a by 2 plus integral a by 2 to a. For this particular function you can substitute 2s by a, this thing, and for this particular function you substitute 2s by a into a minus x. That is only the difference. Also similarly, for the problems with string is plugged in 2 points equal to deflections, that is the figure is like this way. You can also find the solution for this point and again this point and again this 3. You can convert this into three particular equation. That is, you can convert, first of all you can convert into y of x0, you can convert into 3 parts. One is from 0 to L by 3 and L by 3 to 2L by 3 and 2L by 3 to L. Okay, you can substitute, you can find this all function by using the equation of line. That is, you can find the value for our function for this particular line and again this particular line and again this. So you can do the same way and you can split the integral into 3 times. You just refer the PDF and try to solve these 3 solutions. Okay, so whenever the displacement is split into 2 particular function, you can just use that in the Fourier formula. Only the difference is there. Wherever you substitute the integral, you split the integral into 2 different integrals. Using this notion, you can solve the whole problem for the wave equation.